forgot to report for myself. But now I think we're fine. Okay. Go ahead.
For the sidewalk, like in between, if I end up doing that, like, am I need to label it or?
You mean label the sidewalk?
Yeah, like the paint. The area in between, like.
No, you don't need to.
I'll just like.
Yeah, you basically kind of outline the shape of that sidewalk, but you use all the spot elevations to indicate where okay, this is my sidewalk design, and people will understand. Yeah, okay. All right, so that is about the sidewalk. And then let's see. Stairs. Yeah, we addressed the top of the curb. Okay, the TC should be BC plus 0.5. Let's take a look at the stairs. So
I don't really change that much because I'm so confused over like
okay,
how to get the top stairs.
top of stairs will be determined by this distance, by your plaza. Okay, and then this is also determined by your plaza because this whole surface is graded the same. Okay, so the top of the ramp is the same thing. They need to be determined by the contours.
As well as the top ramp over there.
Yes, yeah, both of these are the same. This should be single line. Okay, there's no curve there anymore. Once you have these, you would go down to here, and these need to be the same as the plaza at the back, right? So now, once you have these 4 elevations, you would have a sense of the height difference, right? How much elevation difference you need to overcome, and use that to define, okay, I would need about 20 steps, right? You might need a 19 here. You might need 19 here. Once you have 19 step and you know, okay, the width, kind of this direction, the tread will be a feet, right? Then you kind of mark it on the plan. Then you know how much this is, how long this is, right? And then here you go down by 2%. Now with these elevations and these elevations and the 2% of elevation drop, now you calculate the riser. Okay, the elevation difference between here and there minus the 2% achieved by the landing in the middle is the elevation, the total elevation difference for all the risers. And you divide it by 19, for instance. And that's your riser height. Okay, so that's how you calculate the stairs. All right.
Since you do you mind like label the slot elevations by the bus drive again?
Sure. Okay, so the bus drive, essentially you need 1, 2, 3, 4, 5, 6, and 7, and that one is the CC, so you don't need that one. Okay.
Thank you.
All right. Let's take a look at the divergence swale. Yeah, it looks good. I'm not sure about, you still have to close the 12 contour. Oh, sorry. Still have to close the 12 contour here. Okay, that's the 13. Oh, sorry, 13 contour. You closed the 12, but you didn't close the 13. So I imagine this needs to be moved up a little bit. Does that make sense? Yeah, so this one is not closed. That's the 13 contour. So the 12 needs to be moved up a little. So push this further by 4 feet. Yeah, yeah. And your divergence well works. That shape looks great. Okay.
To determine the slope of the swale, and I need to have a distance between each point of the swale.
Yes.
Like
yeah.
the same or
Right. These needs to be the same.
Okay.
I would recommend looking through how many segments you have and just divide them evenly. And then drag them up and down depending on how far away from kind of the dividing point you are. Okay.
I have a question about
Sure.
the contour. So like for the exercise board, I get points off because of like my 13 contours like killing trees. You know, like why it's killing the trees? Like how am I to close it to not kill the tree?
It's what I did just now.
Oh, okay.
Yeah, yeah. What I did just now. Okay. Same thing here. You wouldn't have two double lines on this side. The curb is only on that side. All right, get rid of that double line there. Let me move up and see. I think we need to look at the ramp here. Okay, you want to put a planting area for the green top, how to show, okay. If you have this, right? There's different ways of doing it. You could say, no, you could put one more little thing here and say scupper for collecting roof water. Or you could put a trench drain over here and say trench drain for roof water. It's basically by labeling. You don't have to design those details out, but you label it so that we know those are for the roof water. Okay. Yeah, it's a simplified way. And typically, in the construction drawing, you would have a sort of a zoom in area, and then on the second page, there's a label here telling what the drawing is, and then you look for the detail in another page. Okay, so reference to a different map. Okay, so ramp here, let's see. 105.71, that looks reasonable. And we talked about needing the side slope, so that's a small change there. We do need to know this. This might be 1096, so you're at probably 1096 somewhere here. Okay, so if that's the case, if this is the 6 contour, 7, 8, 9, 10, that's actually 0, right? Because this is 96.
Mhm.
So I think we are, we're missing some contours over here. We are at 5 here. So labeling, that's wrong. Okay, you're off by 5, 4, 3, 2. We are missing 2 contours, 1 and 0. Does that make sense?
Mhm.
Yeah. So it's likely that you need a longer ramp. I would actually fix the top FFE and the bottom FFE first, and figure out where 96 is. You know what, 96 is very likely going to take this form. Okay, this should be the contour form of 96, and then you go up. And basically now you know how long you need the ramp to be, right? And then you could start revising the shape of it. Yeah. All right, but these contours are connected pretty well there, right? Okay, so I think that's all the questions you listed. Anything else?
I just want to make sure about like how to calculate the curve cut because I got most of it wrong.
Yeah.
So is it like based on the spot elevations?
So all the curb cut, it's basically the bottom of the curb.
Okay.
Yeah, they're the bottom of the curb and should be based on the parking lot contours. Right, and then the BC and the TC you just add 0.5.
So you're saying like bottom curve and curb cut are the same?
Yes, you do not, when you have a curb cut, you would say CC/TC. You do not need another BC because you don't have a curb there. Yeah, so for instance here, if your curb cut is over here, then you're at 107. Right, or slightly above 107 if that's the case. And all these calculations are correct. We already checked those, right? So essentially you just calculate the BC at this location. Okay, cool. Alrighty, no problem. So I'll keep moving. Next I have Evelyn. Oh. Okay, let's see. Am I missing bioretention area near the top of the, yes. Yeah, we need to add that one in. Because otherwise, the whole thing will drain down to here, right? So you need one more over here and you have room. Which direction should the slope arrow? Your direction is correct. You should always slope from the building. Building should be the highest, right? Building should be the high one and it drains away from the building, so your slope arrow is correct. And then the B wall here should be, if you have, if your contours here are correct, will be between this one and that one. And I'm not exactly sure which number it is. Let me zoom out and take a look. You have 109 there, cool. And 1009. So we're missing a couple contours at the back, right? You have to have these contours laid out so that we know, for instance, if you don't have a wall here, your contours don't stop here. That makes sense? Yeah, so honestly, I think your wall would actually continue somewhere here. Yes, and once we get down to here, let's see. We're at 1009, so we need a 1108. If my 1108 is, sorry, 1008. It seems your 1008 is somewhere here. Is that right? Yeah, because your 1008.1 is over here. In that case, you might have a hard time connecting back down. So remind me, is this 0? That is 95. I think that's right. So 0 is over here. And 95 is over here. Can you see if my 98 is over here? It's gonna be really hard. Yeah. Because if my 98 is here, I'm really far away from getting back to 90 here. Right? Because this is already pretty steep over here. And I need to fit in 7 contours in between. So let's see if we can lower the TFFE a little bit. So if we can, for instance, if we enter from here, we're probably at about 108.5. So we can lower this by 0.5, maybe 0.5, and my 8 might be able to be somewhere here. 25 foot. That's reasonable. So my 98 might be here. That will make it easier. And then so one way to make this work will be make your plaza a little bit smaller. So then the slope here can get steeper. Right? Once you're off the plaza, you can make it steeper. Then you would be able to more easily get back to 90 over here. Does that make sense? Yeah. So we will aim for instance, my 98 to be here on my ramp. Okay. My 98 goes like this, connecting back to the other wall here. And then that means I would have, 9, 10, 11, not 11, actually 0, 1. Sorry. Let me try to correct that. 0, 1, 2, 3, 4, 5, 6, 7. We're at 8 here. So you have room. You have room here. Does that make sense? So your 7, the 7 is over here, right? So you actually have room to make this area actually flatter. 7, 6, 5, 4, 3, your 2 can be a little bit further away to make this area flatter. Okay, so your 2 can be here, and then 1, 0, 9, and then 8. Okay, so your contours, you have enough contours, that's great news. Now all these labels should be revised. Okay, these labels are not correct. We're going down to 0, 0 instead of 1, 1, 0, 0. Can you see that? We're off by 10 here. This should be 99. All right, so you have a wall here, which is great. This basically solves the connection of the contours problem here. And 98, once we get down to, and then you need to figure out where 97 is over here, 98, 6. So basically you need to fit in like 7 contours in between the 90 and the 98. Okay, and you need to see if you have enough room. If not, we still have to push.
Why can't you just like wrap them around the plaza?
We are wrapping them around the plaza, but you are at 98 here. Oh, sorry. We are wrapping it around the plaza. This is 8, and we need to get down to 0 here. You have 7 contours within this area. Right, we are wrapping it around, but we need to make sure this is not exceeding the 25%. Okay, so so the 9 contours for now, this is the 9, and 9 would be hitting the wall there, sorry. 9, this is the that's your 95. The 95 would not need to hit the wall. You're trying to connect the 95 to the 95 somewhere here. And 95 here is, well, maybe let's get a little bit more serious, just laying out all these contours in between. So we have 7. This needs to be okay. If this is not off the plaza, then that cannot be there. So unfortunately, you might need to do a little bit of a change so that your plaza will connect to your ramp. Does that make sense? Yeah, so you need to get down to the plaza and end the plaza somewhere here with 98. Again, I'm not measuring, so I'm estimating, but these are the contours you would need, right? So you need 7, and it's gonna get pretty steep. 7, 6, 5, 4, 3, 2, 1, and then 90. So we're getting pretty steep. You need to measure to make sure that the spacing works. This is the sort of the consequence of having a FFE that's a little high. But it's not like, you can't solve it. You still have a way to solve it, but you end up with a pretty steep back. It's like my building is high and my bottom is low, so this needs to be steep. If my building is low, then the back wouldn't be so steep, right? So that's the reason why we need to do all this connection. And then the 95 is over here, and I'm at 95 somewhere here. 8, 7, yeah, that's my 95. And my 6 should be connecting some like that. And 7 going to here. So it looks like only your 8 needs to hit the wall. Your 8 will be hitting the wall, and the other ones would be wrapping around your back plaza. Okay. And you will be evaluating, whether or not you'll be able to connect. So for instance, just having the wall up until somewhere. Let's see. You might be able to end the wall a little bit sooner, just after 98. But that's after sort of your imagination of this area, and then you decide, okay, if my wall can end there, and then these can just basically connect through. That makes sense? Okay. All right, so that's the back. How should you label the stairs? Okay, let me clear this portion and then zoom in. If you have 4, I think you have more steps than necessary. So this is 7, and then that is 9, so it's 16. Yeah, that's about 8 feet in difference. So it's about 16 steps, and you have more than that. And I would consolidate to 2 flights. You know, if you consolidate to 2 flights, you need top of stairs, bottom of the stairs, top of the stairs, bottom of the stairs. You do not need these, okay? And then you would have a slope at each landing. And then you would have the dimension of the risers and treads, and how many treads and risers for each flight. Yeah, for each flight of the stairs. All right. Okay, so that's the stairs. Yeah, you need a retention here. And that's why we have to push the plaza to be smaller, because otherwise you won't have any space for the retention, right? Should we show the ridge line? The ridge line stops right here. It stops once it hits the front of the building, so you do not need to extend it over. Okay. Once you kind of connected all these contours, the B wall will be determined by which 2 contours are the nearby ones, right? If this is 99, that is 98, this will be 98.5. Okay, so it needs to be depending on the final proposed contours, right? Not the existing, if you need to change them, right? And I think you wouldn't need to. Okay, so next one, how do I do the retention here? That's a little bit, yeah, that's a small one. I would suggest that, yes, this is only the entrance, but the bulk of the retention could be here, right? And then it's the same. That's BCDI 1108.90. And then you have a DI, you do not need an RDI, but then your LP would be 7.9, for instance, right? And then you would have a 7 contour. That's a little strange. Let's see. LP would be 1107.9. Yeah, you have a 1109 contour, 0008 contour. And which means we do not, yeah, you do not need a HP, because everything else is higher. Everything surrounding you, 109, 10, 9, it's above your retention. This is 109. Yeah, that's right. Okay, so that is that one. I think that's all the things that you listed. So obvious major issues. Okay. Obvious major issues. That's a hard one. And I would make these a little bit bigger and push these to the 4-foot limit. Okay, these seems very kind of squeezed, and you seem to have more room to move the swale contours to be able to accommodate a more spacious retention areas here. Okay, yeah, try to measure these, make sure they are 4, and then enlarge those ones. And yeah, I would add retention here and there because you have a pretty big medium. And I think that's a missed opportunity if we don't have retention inside. Contours here seems okay. Yeah, that one needs to be bigger. If you can, push these contours and make this one bigger because this is the end, right? Those two are the end. Yeah, I would say keep working. Yeah, good. All right, let's see. Delaney here? Okay. So, retention location. First impression, work on the on your line weight. Okay, line hierarchy. The pavings are a little too strong, and then the contours, it's a little hard to see the contours. Label the contours on the parking lot as well. I know you labeled on this side. It's better to label on that side too. So that, and then location, you have it somewhere over here that works. This one work. This one, and I would have another one over here. Because you need a curb cut over here. Your swell goes right through, and this one is actually the outlet. So you need something here. Your curb cut is not over there. This is the plaza, right? The plaza doesn't have a curb. So this is a single line. That's the plaza boundary. That's a single line. But I would cut it down. I would have this be open and this be a retention because you need for it to be open. This is where water comes out. So your plaza paving would stop somewhere here. Okay, that's your plaza. And that needs to be a retention. This has a retention, so that's good.
So the retention next to the pink, but you just erase that and just put it where the pink is now.
No, this one stays because you still have a little bit of an area.
The one next to it.
The one next to it, yeah, you don't need that one. Because this is your swell line in the middle here. So this one, well, this one receives from the plaza. And you have something over here. And in that case, I think it's okay to get rid of that one. Okay. You would have a reason to have another one if you collect all the water up from the plaza and then direct it out. That's if you want to keep that one, this should be designed that way. If you don't keep it that one, this is the one that's critical. That one, okay?
Can I do both?
You could. I think doing both is a good idea. But the you need to have a trenching along this line to be able to make it work.
Okay.
So that water will be directed out there, and this collect all the water coming from the top plaza. Okay. Yeah, that's a good way to separate the plaza and the driving area. Okay, so that is on this side. On the other side, I can't tell. Okay, this one is one that's not receiving a lot of water. Okay, this one is not receiving much. Reason being you would draw from the curb cut, right? Perpendicular to a contour, and that is how much area you're receiving. That's not a lot, so I don't suggest doing that one there. And instead, these areas actually are receiving water.
Yeah, I didn't know how to put them in there just with the shape is so weird.
The shape is irregular. The water is, for instance, draining that direction, right? Let me change to an arrow. Water is draining toward, and you could have an opening somewhere over here. Now, water will flow along the curb and it will enter from the curb cut down here, right? That could work. for the first one.
What would be the?
For this one, your curb will be your high point.
Okay.
Yeah,
You want
Um,
to specify?
yes. In that case, you would just say, no, TC/HP. Because your top curb is essentially your,
The whole curve?
on the lower side of the curb. So essentially along the lower curb. That's your lower curb. Yeah, that should be your HP there. For the sidewalk here on this side, I don't suppose you have all these curbs. Let's see. That needs to be a single line here. Yeah, I believe that's the case. Right, that's the curb. This is not a curb. On this side, this would be the curb, yes. And on that side,
The two oval shaped things are like education,
right, but your curb is only between,
so you don't need that long.
you do not need that double line here. Yeah, you need a line. I know you have a sidewalk around, right?
Yeah.
Yeah, that's a unique design, but your curb is only along these areas.
Right.
That's your curb.
Okay.
So no double line in the middle, and that would help eliminate some of the confusion. Let's see. Yeah, in both of these areas, you could have retention because they are receiving water pretty effectively. Right? You can have a curb cut somewhere here. And then that one, you can have a curb cut somewhere here. And the whole thing would be the retention. And the sidewalk will be just floating above the retention. Does that make sense?
Mind drawing?
So it's ignore when you design these two retention, ignore the two lines there. And then the principle is exactly the same as the other ones. It's just you have a retention, but you have a floating sidewalk above the retention. Does that make sense?
Yeah.
Yeah. So in that case, in order for it to not create more confusion, you would turn the segments that are so this sidewalk. So bottom ones, you would design exactly the same as the other retention area. You would turn the line weight, the line type to a dash line here.
Okay.
Okay, so that's to signal, okay, this is above the level of the retention area, right? Okay, so the same with this. So then we would know, okay, you understand that this is a sidewalk that is on top of the retention. And those lines wouldn't appear too conflicting with each other, right? All right, so that's retention on that side. I wouldn't do anything on here because you don't have enough water to come in, right? And we could do something here. We could, but it's not a huge area. It's this area, that much area. It's not a huge area, so it's okay if you don't do anything. No, it would just keep flowing down, right? So you can't add something here, but you don't have to. All right, so that's on this side. On the other side, yes, retention here, great. Because it's draining toward here, toward this direction, you don't actually have any retention on this side. Let's see. Yeah, you don't have any retention on this side. So this one would just be, it would just be a swale like this, that's correct, but you wouldn't have retention in the middle. So it should be straightforward for incorporating the swale here. You wouldn't need a wall here. Okay, having a wall here is actually, you have to deal with the runoff coming down from the wall and directing it down. It's a little more complicated. We talked a little bit about that. You don't need a wall here.
So the issue was that the slope lines were like too close together, so how do you suggest I fix that section?
The slope line too close together, well, we haven't connected these contour yet. We should start from this side, right? Start from the 13 and then move to the 12. And these should be 4 feet apart. Then you can see how much area, how much room you have for connecting the contours here.
Okay, so then I can just connect the lines to the lines that you just drew.
Right.
Instead of having the wall there.
Yes,
Okay.
yeah. Having a wall here is not helping. You can see your kind of constraint point is over here. This is where you have the least space, not necessarily here. Okay, yeah. Retention here, good. You need retention here. The swell goes along and goes out here. Yeah, this is where you need that retention to connect out to there. I would stop my pavement somewhere here. Okay, because people won't stand over there. There's no room, right, to get up from there. So this is where your water should come out to a retention. All right, so that is
Wait, where would the curb cut be?
curb cut being here. Yeah, curb cut should be there. All right. So that's the places you need to have retention. Let's take a quickly look at this one, all right, and see if that's correct. I need
I know
to,
it's not correct, I just like, I couldn't figure it out exactly.
so your BC, it looks reasonable if this is an 8 contour. And your RDI looks reasonable. HP is correct. And contour is a 107. And the contour here is 08. Right, correct? You have an 08 contour. 07 contour, that's correct. So the label, the thing that is not correct is you have a 6 contour, no, sorry, 7 contour here. And then you would have an 8 contour. Okay, and your 8 contour is where the high point should be. Because this is 8 and that is 8. That makes sense? Yeah, so your 8 goes like this. That's the 8 from sort of, after dropping the parking lot, that's your 8 contour. And you have a 7 contour because your LP is lower than 7. You have an 8 contour because your top of the curve is above 8. Right? So this should be 7, that should be 8, and your HP needs to be between the two 8, and that needs to be 8.5. That's all the changes you need for this one.
So,
Yeah, it's not far away.
then the low points, like, I'm not sure where to exactly like, place them.
You place them across the landscape, right? At both ends, and then you can lead into the middle and say 106.5. Now try not to use an arrow, just use a line, a leader line. Okay? Yeah, otherwise people will kind of confuse it with the slope label.
Can you just make that its own thing? Like,
Leader line would be the same as your cross, your spot elevation cross sign. Yeah. The same as your spot elevation would be the kind of, you look at them together, you would find them kind of being part of the system, right? Yeah. Okay, so that is the retention.
we kind of went over that one already.
Yes. Staircase. So this one, the TS was calculated correctly. And the bottom should stay here, that's right. And it looks reasonable. No, all these elevations, their connections, they look reasonable. you just need to label with how many risers at what dimension. Does that make sense? You need to go back to the grading class where we talked about stairs. Number of stairs at what dimension? Sorry, number of risers at what dimension? Number of struts at what dimension? That's how you label the different segments here. Okay, so you need at like three more labels. Those labels is, for instance, if this one 1, 2, 3, 4, 5, 6, you would say 6 struts at what dimension, right? And then 5 risers at the dimension. Okay.
Yeah.
For each of them, you need to label that. Okay, so that's the stairs. The calculation seems reasonable. I would not start with exactly the corner. People need anticipation before they get into this the stairs, right? They will trip if you make the first one flush with the corner. So I would start at least one more step into the same thing. I would move this inside this one, the first step there. Okay, so that's the stairs. Okay. Push more contour. Yeah, we did talk about this. Okay, good. Anything else?
Yeah, on my, final 4, because then I need to push more contours on the road near the driveway, I don't know what that meant.
So, we don't know how the 1112. So the 112 seems to be kind of going along here and come down the 1102. And the 1102 kind of disappeared, right? It kind of connected to here, which is not correct. Does that make sense? No, your 1102 needs to come back to, it needs to find a connection to this 1102 here. The 102 comes out here and then go this way. There's 2 ways to connect the 102. You could close the 102 like this once you close the 13 here, and then make this connect to the 112 here. And then you can start the curve somewhere here. Then you don't have to change. You can connect the 112 directly over. Does that make sense?
Yeah.
Yeah. So, I am not sure. I think you might have a little bit of 102 coming out of the curve here. You need to double check. Now, looking at the distance here, this looks like 102 on the landscape. Okay. Yeah, you offset by 25 here because this is a parking lot contour and that is a landscape contour. The spacing should be 25. Okay. And I think there is another 102, 1112 here. And you can remove part of the curb, so this can connect over. And this can go directly, but your curb needs to start somewhere here for it to go across. Okay, 13 can stay, but your curb needs to be moved. So that's the first way of connecting that contour. Another way would be, say, you know, I keep this, right? I keep this, but this one would be connected back to the 12 here. Does that make sense?
Yes.
Yeah, either way will be fine.
Okay.
Okay, so that's the road contour. All right. We're good?
Yeah, yeah.
All right, no problem. Is Tim here? Okay. So not sure which contour lines these are inside the parking lot. Yeah, okay. That's fair. It gets confusing here. So when we look at the big picture, we have our 04 going through like this. And then 04 needs to be somewhere in the middle, right? there is a, sorry, 05, kind of crossing like this originally. So you should keep this portion of 05 in the medium. Does that make sense? Yeah. Yeah, and then I suspect there's a little bit of, I'm not sure, double check. Maybe there's a little bit of 1104 over here, but maybe not. Probably not. Okay, so this portion stays inside the medium, but the shape of this can change however you want. Okay, the shape of this can change however you want. You just need to remember because of the curb, this one cannot disappear. You have to have a 105, which are connected to that spot and that spot. However, the connection take shape, it doesn't matter. Okay, so I could completely go just around, around it and just connect like that. That's totally fine. All right. So now we're looking at your retention design. You have an entrance over here and another entrance over there. Okay, this one is a little bit lower, right? And that one is higher. So I would need to calculate the elevations of your retention based on the lower one. The lower one is this one. Okay, that is this one. And that is 1104.35, which would make your water level, the highest water level, be at 104.35. And the HPs here, okay, honestly, HPs, in this case, because of how little area you have here, your HP should be just your top of the curb. You use your top of the curb as the way of, kind of preventing water from keep flowing down. Okay, let me try to zoom in. So this is where you have those connections of your contours. Let's just keep them in mind. And then these are my curb cut. And the first one is a little lower than the second one. And my curb cut is 104.35. So my LP would be 103.35. Okay, so the contour that I have inside is 104. And then another 1105 that we just talked about, right? So you would have a 1104 contour that is a closed contour. You can even just say the whole thing. The entire thing is full. In that case, your 1104 contour will just run through the curb cut. Does that make sense? The curb, yeah. The 1105 would go like this. It's all around the curb because you don't have enough space, and we have to, in this case, you're basically relying on a double wall system, right? A double wall system, instead of saying when others have room, we're designing a system like this. Okay, when we have even more room, we're designing a system like that. But now inside of this limited area, we don't have any more volume. We have to use the curb as the walls for the high point. Okay, yeah. So this will be the 4, and that will be the 5. And so let's see, LP equals to 103 cc, and your So basically you are just using the top of the curb as your HP. Okay. So you would label on this side. On this side here, around the lower edge, TC/HP. Okay, TC/HP, and you calculate that TC elevation based on where these they're located. All right. Okay, so that is for the limited medium area. That seems to be the only one that you listed. Anything else? Yeah. So you would use the same method. Well, this is relatively easier than the ones over here. That one needs to have a DI, but the principle is essentially the same. Okay, it's a little more complicated on this one because you have a swale going through. So you kind of have to cut it open over here. And that's where your curb cut should be. And there's another curb cut over here, right? This is the lower one. So the calculation inside needs to be based on that one. Does that make sense? You, in this case, you cannot. This is a dead end. This is a dead end. And this is also a, I'm sorry?
If I move that one down.
Well, if we don't have this one, that's okay too. But just like all the water will just keep flowing down and into that one. That's okay. Okay, but if you want to cut it open, you wouldn't cut it open in well, you could cut this one open, but the whole thing needs to be determined by the lower one. Yeah, otherwise you flow in and then you flow out from the other one, right? Yes. So that's just, I want to remind, this is a little more complicated than the other locations. Okay. I'm gonna do a really quick look and see if there's very obvious things that you need to address. We talked about the trees over here last time. We talked about the stairs needs to be worked out. I think we talked about the FFEs. Yeah, we talked about the FFEs. They're not being correct at this point. We need to make sure these are calculated before you can see if the ramp is correct, right? You don't need retention on here, but that one needs to happen. This one needs to happen at the end over here. Yeah, I would push forward on the retention areas first and then go back to the ramp and then the stairs. All right. Okay. Okay. Oh, you're welcome. Henry?
Yeah.
Okay. So, yeah, you should. That's a good place. I would say yes, yes. Even this one would be yes. And this needs to have a curb, right? The curb should be like this.
Should I just combine those kind of?
Oh, honestly, let me see. Let me zoom in. We're missing some curbs. We should combine. And obviously we need curbs over here, right?
Yeah.
And then this curb should be just looking like that. No need to have the middle line there. The curb for this one would be like that. Okay, no need to have double line over here. That one is working, but no, rounded at the corner here. That's a curb for sure. This whole thing is a curb. Okay, so those are the curves. That needs to go around like that. And I know at some point over here, you have sidewalks. Seems like this is the divide for the sidewalk. Yeah, okay. Yeah, and then you have a green area there and oh, okay, I get it. Okay, so that's the curb. Okay. I'm checking if you have missing retention areas. Those are good. This is going that way, so it's worth doing something. Well, we'll just make this green. And
Make that a
we need
retention
to,
area.
right, we need, well, this will be green, not necessarily retention because it's not receiving much water.
Yeah.
But you need something here. Can you see that?
Yeah, there's a lot of changes that happened, like when I did the, I changed a lot with my design.
Yeah,
And then I hadn't accounted for that obviously in my original plan, but
yeah.
okay.
So what I would actually recommend is not to have so much of a sidewalk over there. I would instead make this area a retention area. And I know you need ramps. You think about something else to make the ramp happen. Let's see. That's okay. This is okay. But it's just this area. This is not receiving much water. So I would just make this green. You want an ADA. This is where the water comes out. What we could do,
Would I just put a drop inlet there or would I put a curb cut? There's like a sidewalk in between.
yeah, well, if you put a drop inlet there, it's any of these, it's not treated. So that's kind of a, yeah, so that's your dividing line. Well, fix some of these. I think it's yours did a shift. Let's see. Feels like it's shifted. Oh, okay. It actually shifted a little bit. So all this water, yeah, that's not enough. This is the only area that this is treating. Well, I would say let's do it because we can use anything we have, right? Otherwise, the rest is all going down. The whole thing here is going down to this area. If you don't want to change the design at this point, I can understand. I think what we can do is let's just do a transferring over. So we use this area. Oh, sorry.
Oh, okay.
We use that one.
Well, I can definitely, I mean, like, that's not a big change to just make it like a 6-foot sidewalk around the radius of that drop off.
Uh-huh.
And just make that the retention area.
Yeah.
Yeah.
Yeah, let's do that because I don't want you to get rid of the ramp here either because you sort of you had this thing going on and I think it's a good thing. And if this is all green, these people won't be able to walk easily over either. So I think this is something that is kind of coming out of the design that is valuable. So let's just do a trenching and then we use this
Yeah.
to treat the water coming out of here. Okay. All right. see. Should there be, yeah, you need the dropping line over here. That's right.
And then where would that,
You place it
how do I,
right before
Yeah.
you get on the ramp.
and then how do I like annotate like where it's going?
You don't need to.
You know?
You don't need to. Previously, in previous years, we had an exercise after this, or integrating the final project, you have to indicate where pipes are,
Yeah,
but we got rid of it.
okay,
Yeah, basically you would just have a DI,
okay.
yeah, for that one.
And it's like assumed that, and then on the other side, there'd be like a bioretention and it's assumed that it would go there, I guess.
There would be a network of pipes underneath your parking lot and eventually goes somewhere.
Yeah.
And it needs to be tied into the municipal system as well. Right, so that becomes, no, too complicated for this whole project, so we got rid of that. Okay, so that one keeps, how did I do my ramps correctly? Let's see. So for this one, I wouldn't do it right here because you basically, no, folks are walking here and folks are walking there. This is sort of the tightest space.
Yeah,
Yeah. You have flows of pedestrians kind of converging here. I would probably just do it where you have more space. Put the ramp over here.
and then what are the dimensions of that, like the top versus the bottom? Like-
So you can make it pretty big, right? The smallest one, you have the example of the smallest one. The 8.33%, it's basically, you get above a 6-inch curb, 0.5. The length only needs to be what? That's 12 multiplied by 0.56 foot.
Yeah.
Right? So you can make it actually, pretty big, somewhere over here. And then have a flare,
Mhm.
right?
And then the flare, so it's six different spot elevations is what I should have.
Yes,
Okay.
and then a slope there.
Okay.
Yeah. And for here, you don't necessarily need a ramp, as long as you have a ramp, right?
Yeah.
So I would say folks are walking all these directions, you want to try to stay away from the major flows. So wherever you have the most space, I think that's a reasonable location. Okay. Anything else? I think the 5, the 6 is connected to the wrong contour. We connected to the 5.
Oh, my bad.
Yeah, so let's fix that one. Yeah, that's the only place.
My bad.
Okay,
Um,
go ahead.
and then. So I added that car turnaround. I'm wondering, obviously, there's gonna be water at the bottom of it, and. Did I just add
Yes.
another?
Yes, did we? I remember, I seem to remember this. Did we talk about it?
Well,
This-
yeah, cause I changed it and I had to like shift like my entire parking lot over a few feet. And
Uh-huh,
had to like add parking spots some places and.
right. The key thing is you need to know if you would have standing water by moving this line to here. So you can see whenever this line intersect with your curb, I would know, okay, this is the lowest point, right? Once we have the lowest point, I know if I don't have a curb cut here, water will pond here. So I do need to cut this open, right? Cut this open and this becomes its separate thing. Of course you can combine these two, but if you combine these two, you can see that I will need to use that as the elevation of the entrance.
Yeah,
So you would cut down pretty deep here.
yeah,
So if you want to separate these two, you would have one here and one more there,
okay,
right? You can separate them, and I think that's even a better design.
Yeah.
But you can also connect them. But just so you know, if you connect them, it will be steep here because you're cutting down. Okay, it's sort of the scenario where we have our parking lot retention, right?
Okay. Thank you.
All right, cool. Good questions. I'll move forward then. It's Gabby here? Oh, you're here. Okay. So, arrange the contours to 50 feet, great. Do I have too many spot elevation points?
Yeah, that's like they said it.
Right. I wouldn't say you have too many spot elevations. In fact, you would need more later on. Okay, you do need to, for instance, I understand this spot is probably meant for that one. Meant for that one, and all these you would need spots, right? So a key thing, I would align your spot elevations like this, parallel to the bottom of the page. Okay, so we don't need to turn our heads around to find the spot elevations. So these ones I would actually just line it up along with the page, bottom of the page, right? So you definitely don't have all the spots yet, but I don't think it's very far away. Like for these, you would need 2 of them here, no, 2 of them there. Just make sure you hit all the tangent points, right? Hit all the tangent points. And then you might want to kind of divide and conquer, say, for this hour, I will work on the parking lot on this side. And for the next hour, I'll work on the road segments, so that you kind of separate it a little bit, and then you keep track of, okay, I have finished this area, right? And then you don't need to kind of, go back and forth in different areas and troubleshoot where I miss my spots. So I would say you have about 80% of your spots at this point. And that's a rough estimate. Okay. Let's see, done a few BCs, and how do the calculations work? Let's take a look at the sample area. You've done some of these here, right? Yeah, so 108 contour, that's 08.54 for 6. And for this one, we need to know if you need actually both of them. You know, we need these at the tangent points. We need the quads, right? I will basically use this line as the reference point to do the quad. So that one, this one, that one, this one over here, and we don't have any over there. So I'm not exactly sure we need this. All right, but the calculation of them seems correct. And then we have one more here. Yeah, there's a tangent point over here. That's the 107.72. They look pretty good. So these calculations look good. That look good. This one look good. And my leader line, I would not do it from the cross sign. I would do it from exactly the same spot on the curve, but they're close enough. Okay, they're close enough. So not the cross sign. It should be the location on the curve. Okay, so in the future, make sure you start with the curve location instead of the cross sign center. Right, but it seems like the spot elevation calculations are on target. Okay, so that's about the spots. Pavement. Yeah, from my visual inspection, I think they are evenly spaced now, and they're parallel to each other, so that those are good signs. How can I calculate this? Correct, H.
It's like measuring the the two arrows, right?
Measuring the two arrows, meaning,
Like the two that have an section line. Or across the parking lot and then the one across. Yeah, that one.
you mean this one?
Yeah. The HP.
Calculate the HPS, yes, we do need to know where this is. Your HPS is right here. Your HPS is here, and then you use that one, you just do the same thing. Project a line over here to the 1109 contour, and that's your HPS. Okay? It will be between 09 and 08, right?
And then for the two LPSs, I would need them.
Yeah, you would do this. Yeah, you would do that. And the same thing on the other side. Now, let's take a look at the FFE.
I tried to arrange the contours, so
Mhm.
the 109 would still be close to the FFE.
Mm-hmm.
So I didn't have to like change it, but I didn't have calculations that's still on, because I didn't redo those.
Yeah, I believe the top FFE and the bottom FFE are still not correct, because we went backwards. If this is 1009, you would, so this is correct, right? But you need to, this one is higher than 1109. And that one is higher than 1109, and you would do the calculation based on that distance. So this would be 9.5 around.
They're supposed to be higher.
Yeah, because buildings are higher than the plaza, otherwise all the water will drain into your building, right? So this will be, TFFE would be your about 9.5 here. And then the bottom FFE would be 99.5. Okay, and then the other elevations, you should calculate, correct them based on this 2% there. Okay, so our ramp, you still need to correct that, because the BR right now is around 99.2, something like that.
You have mentioned the V shape. Do you think I should just change the ramp to that?
I mentioned it's better for the ramp start in the plaza, because people don't need to, well, once they get off their car, they're in the plaza, they would see, okay, there is a way for me to get down, right? If people cannot take the stairs, they can see this and then they could get down. The folks that come out of the car on this side wouldn't be able to see the entrance of the ramp over here. That's why it's better to put the ramp over there. Okay?
And for the 2% and what that was like behind the building, so those would still be okay.
Yeah, those are okay. Yeah, this slope also needs to be in this direction, perpendicular to the contour. Okay? Yeah, that 2%. All right, so that's about the ramp. Let's take a look. Yeah, slope arrow looks fine. Slope arrow looks fine. You just need to make sure the direction is correct. All right. And then swell here, correctly connect them.
Because over like the old swell, so I kind of have trouble to the new contours. Yeah. I know something to do with like the existing ones, maybe back to those.
Your contour here seems to not go far enough, because 1112 is over here. So I cannot see, you didn't plot the existing contour, but no, if I remember, there is a 13 over here. There's another little 13 over here. And you essentially just need to have if your swell starts here, yeah, these are the old contours that you have the 1110 here, and your 1110 needs to come back over here, right? And then come out like this, and then come down. Does that make sense?
Yeah.
And you have a 1113 over here. So basically, you would even kind of more relatively even divide these two and say this is the 13, that's the 12, that's the 11, and that's the 10. Okay, so your 11 essentially will just go like this. Okay, sorry, I drew it, didn't see the sidewalk there, so it needs to become like this across here, okay? And then from the middle, you do 11, connecting to 11 down here, and the 12 goes like this. Does that make sense?
Yeah.
With the
so
12, yeah,
slope of that entrance driveway would be
that's okay.
the-
That's okay. Your entrance drive here, it can be steep. It's important for it to not be steep for this portion, and for that portion. Right, so this is okay for it to go up to until like 14% is acceptable. So you're fine here with a steeper entry drive. Otherwise, you won't have enough space, right? If you want to, you can keep pushing it, but I think it's okay not to keep pushing it into the neighboring land. But you do need to change all these contours, all right? So 18,
Would you recommend like finishing the contours first or trying to read spots?
I would finish the contours in this area first. Yeah, that's a major thing, although you don't need to calculate spots based on these spots. But for instance, the 11 and 12 and 13 will be determined by those contours, right? Yeah, I would finish up this first. Finish up this first. All right. Okay. Anything else?
But yeah, the contours right underneath the building, no.
Oh, these ones. Those ones I would have to see the pre-existing contours. Otherwise, I won't be able to judge. But I think you would have a similar problem with, I remember talking about Evelyn's, where they have many contours stacked underneath the back plaza. You have a similarly high FFE here. So if your FFE here is 99, I suppose there will be a lot of contours, for instance, between your 99 and your 90 that you need to fit in, okay? Yeah, plot that out, revise the TFFE and BFFE, and just offset them by 4 feet and see how much you have to push back to fit all those contours. Yeah, you would have a little bit of a challenge back there, but I don't think it's not doable. I think it's doable. If you run into difficulty, you can watch that portion of the review. Okay,
Sure.
all right. No problem. Is Woody here? Is Woody in the room? I don't see. Okay, if it's not, I'm gonna move forward. Is Luke here? Okay. So, swells work. I would put in one more retention. Okay. I would put in one more here. Oh, scale bar. Scale bar should be in here. You have it here, okay? You could move this down. Move the sheet number down a little bit, or you can put the scale bar over here. That's fine. I would opt for putting the sheet number, move it down a little bit and put your graphic scale over here. Okay? So how can I solve the issue here with the slope being greater than 25? Do you mean this portion?
Yeah.
Okay. Well, And that's the 9.5, 9.5. And for now, your contours are not connected to the contours on the ramp, right? So that's the first thing that you need to solve. The ramp here, I don't believe we can get down to 8.05 here. So you need to revise the elevation here based on the calculation to this line. Okay, I think it won't be as low as 8. I think it's probably 8.5, something like that. So we need to first correct the TR, top of the ramp first. And then we need to think about what's underneath here. This is 9.5, that's okay. And 99.5, and this is 98.75. Those numbers look good. One of the reason you have run out of space here could be you were trying to connect too soon to the upper lower plaza. You might want to change your ramp to being a little bit lower. Okay, let's see. And another way to do it would be, I squeeze more stuff here, right? Squeeze it more like over here, then this portion will be less steep. Either way will be fine. You can change your ramp so that it goes down like this, so that you have more room. You could also change the contour shape over here, or to go up a bit. Does that make sense? Yeah, so either way, you could try, the first option first. But that is all based on having the right elevations. Having the right elevations for the top of the ramp and the bottom of the ramp. Okay. Now let's suppose we don't change the shape of the ramp, and let's take a quick look and see what your calculations are. So if we have a 99.50 here, well, this would actually be lower than 99.5, right? Because you have a slope down here. So this is lower. Suppose, I'm just gonna try it out, okay? If this is 8, 7, 6, 5, this turning, it's a little too steep. 4, 3, 2, 1. Let me move the 1 over here. 1, 0, 99. So you are close to have enough length, except for this area seems a little steep. Okay, so I would suppose that you can move the 99, for instance. If this is okay. Honestly, I wouldn't have the ramp extended here. I would have the ramp, bottom of the ramp at here, right? Because this is where you land from the stairs. You're coming down from the stairs. This portion needs to be part of the back plaza. All right. This needs to be part of the back plaza. Does that make sense? You do not want this area to slope like that and then also slope like this. They conflict with each other, right? So you want this to be proportion of the plaza, and these elevations should be based on that being 99.5. So I'm gonna say this is pretty close to 99.5. That's close to 99.3, for instance, and your 99 would be pretty close to that line. This is a good estimate of where 99 would be. And so that's good. This is good, and this is good, and that is good. But now we need more space over here. Okay, so it did look like you need a little bit longer of a ramp. So it does make sense to say, I'm gonna just move this portion, move that portion down to here. okay, to here. And that's where you connect to the stairs. Right? That is my new ramp. And I move these down. Sorry. Well, you get the idea. This might be even closer. This might be even closer to the 95. Yeah, this is actually going to be likely your 99. It's somewhere here. Okay. And then that becomes your 98. Now you have more room, right? You're going to redraw this connection. Redraw this connection. Yeah, this will be the turning area. It could go down to about 2% there. So the next thing you will need to do is to make sure you correctly calculate this, the top of the ramp, because it's important for you to have the right location for the 8. All right. So the 8 is important. And then you offset by 50, right? By 50 to get down to the bottom ones. Okay. So that's how you should kind of revise your ramp. But the more important thing is these contours need to connect. Okay. Your 8 here, if your 8 is somewhere here, it needs to come down up to the 8 somewhere here, and then go up, hit the wall. And now I see this, I would actually change the direction of the 8 to the other direction. Does that make sense? So that I do not unintentionally form a swale while I am doing the ramp. Make sense? Kind of.
Yeah.
I would turn the side slope to the other direction. And then I could connect like this. Okay, my 6 has to connect to the 6 of the ramp, and so on and so forth. Okay, so that's about the ramp. Let's see. I don't see other questions. Anything else you want to ask?
I think I'm questioning, usually like my top FFE works, but I'm pretty sure on my, like the exercise 4 rubric, it doesn't drain properly. I might have misread that, but.
Your FFE works here, but it doesn't work down here though.
Why is that?
Yeah, because these are the same. That should be lower than that. Right? This spot needs to drain, so that needs to be higher than that. That is lower than this. Okay, so if this is 9.5, that will be 9.4. And this will be determined by this. So your FFE works, but your corners are a little off. Yeah. So these will be determined by the calculations to the 9 contour. Okay. The same thing. No, that would be lower than 9. All right, this should be lower than 9. Okay. All right. I'll move forward. Is Brendan here? Okay. I'm unsure how to grade the ramp. Okay. Need some help with spot elevations regarding my stairs in the bottom FFE of the building. Need more retention. Any issues with the contours, divergent swales. And okay. So let's look at the ramp first. You had two parts of a ramp, right? You started from here. And then come down all the way to the bottom of the ramp. Well, again, in order to see if the ramp is done correctly, you need to look at the top FFE and the bottom FFE, right? So your 08 is here. Top FFE I will need to see if you have a 9 contour. If you don't have a 9 contour, then your top FFE would not be above 9. Right? So let's see. Are we missing some contours above? I think we are missing a 9 contour here. There's something 9 should be at least partially here. Feels like there needs to be a 9 over here. Yeah. So that's probably your original 9 before you dropped your parking lot. Might be up a little bit and might be down this direction a little bit. But you're missing a 9 over here. And then let's see, where is your original 8? Your original 8 is somewhere here. I'm trying to figure out the direction of the 8. That's your 8. That's interesting. Yeah, there's something with the contour that's not correct. Let me zoom out a little bit. Because your 07 needs to turn. Okay. So let's do the original ones first. That's your original 08. And it's to come down here, seems so. So your previous 9 is over here. And then it goes this way. Can you see there's something? Oh, no, actually you need to come down here. Sorry, my bad. And that goes down here. That's your 9. This tells us this needs to stay. That needs to stay, right? So you have a 9 that is connected like this. And your 7 is actually going like this. Does that make sense? That's your 7. This is a closed contour. All right. And your 08, partial 8, goes down like this and then goes, well, that works. This works. That 08 goes out like that. But I need to remove the part that is down. So it connects like this and then go along the curve and then connect like that. And this portion is coming down to yeah, we need to find a way to close it. Well, so your 08 essentially was now I am a little 08 should be over here. There's a little bit of 08 over here. And that needs to come out from here. That's the original, it needs to come out to. Oh, give me a second. I feel like my brain is frozen. That's the 09, that's for sure. That goes out. 08 goes like this and then cross like that. So I'm not sure what that is, what this line is. This line is probably wrong. This might be a leftover that you forgot to delete. Yeah, I believe so. This is the something that you forgot to leave. Yeah, this comes out there and this one eventually goes out like this, so that's correct. So I should erase this and that. There's a close contour somewhere here, and that needs to go away. And your 07 actually doesn't come over here anymore. Your 07 basically wrap around. So there are a couple things that are not correct. Yeah. Yeah, this is not correct, okay? Because your 07 is essentially forming the swell here, right? So you wouldn't have that and you wouldn't have this. This one would need to come wrap around the 07 from far away in this area. Okay. All right, I think that solves the contour over on that side and 1108. Let's see 1109. Well, you need something. You need something to form the swell here, right? So we're missing some contours on this side. It might look like something like this based on where this is, okay? Offset by 20, no, 50, by 2%, 50, and find out where this contour is, and then do the same for this side. Does that make sense? So we're missing a contour there. And that contour is 9, right? It's 9 contour. And based on that, your top FV could be 109.15. So the whole thing is, let's try to find out your top FV, and then we found out you are missing a few contours, and we make that correction, okay? Bottom FFE is actually 99.15. Okay, bottom FFE is 99.15. And that makes it questionable whether or not the ramps are done correctly. But we'll take a look, okay? Okay, so top FE is reasonable. And we are not connecting to the lower plaza yet. So your lower plaza, honestly, I will just make it like this. Okay, so change the bottom FFE to 99.15. And then you would know what this is in terms of elevation. Here, okay? This could be 98.15, for instance. Could be 98.1 somewhere here. And from that one, we'll start to look for where 98 is, right? By doing the 5%, I'll find out where the 98 is. And then I'll look for the 20 feet away, the 97, 96, 98. Sorry, my bad, going backwards. I found out 99, I will find out 99, 0, 1, 2, 3, 4, and 5, 6, 7, 8, right? I'm trying to, starting from here, this is about, this is below 9, so it will be 8 something. Yes, this will be, for instance, 8.7, and then you use the 8.7 to find where 8 is. Okay, and then you go forward 7, 6, and 5. I would just connect them better. Just like doing this. Okay. Make a good intersection so you have enough room over here for different flows of people to converge. Does that make sense? Okay, so this is how you work on the ramp over here. Okay, and honestly, by doing this, you have 2 ramps. You have another ramp along this way, so that you need to calculate as well. If you want to get rid of that ramp, it's okay too. okay? If you say, oh, that's too much to calculate at this point, I want to simplify things, you end the plaza over here. Oh, yeah, no, you can go from this ramp and down to the stairs, that's okay. If you want to leave this one, you just need to remember, you need to calculate this one as well. Okay? All right, so that's for the ramp. Okay, let's look at the retention area. You have all these are draining down here. These are draining down there. You have one more here. 1, 2, 3. This is all right. On the other side, you have this one. We have that one. Yeah, that one is essential because otherwise it won't be able to drain. Let's do, well, this one is not receiving much water, so it's okay. So in terms of the number of retention, I would just add one more down here, because we're getting low in this area, but there's only 2 like upstream, right? In the higher area, but I think we need one more just in between here. And definitely we need more at the bottom of the building. And that one goes down here, so that's okay. You can turn this one into a green area as well. I think it's a good move there. And you might want to enlarge this because you need a ramp, okay? You do need a ramp here, so make this bigger, the sidewalk bigger. You also need a ramp over here. Okay. Then, yeah, that's it for the ramps. And for the retention areas, let's see what other slope wise, you have the slope over here. I would do one more here. Slope over there for the plaza. And once you know, I would change part of this, okay? I would basically reshape the swell so that the shape is more pronounced for the swell. And also the divergence one is to go, no, the tip of the swell is to go beyond the edge of the retention. I would cut this down, okay, so that I make more room here for my swell. Like that, I could make this more spacious, make my retention more more spacious instead of this area. I can cut this down. I can move the 1102 even closer to the tree to make more room for my retention there. Okay. Once you graded this area, you need a side slope here as well. You need slope for the back plaza. Here I would probably just use maximum because it's not necessarily uniform. Same thing over on this side. You need slope arrow for the swales. Okay, for the swale center line, you need that. This is wrong. Your slope is going this way, okay, at 2%, right? So essentially, all your uniformly sloped area needs a slope arrow, okay? And your stairs, if you have a landing later on, you would have slope arrow as well. Your ramp needs slope arrows as well. Okay, so those are about the slope arrows. I don't see an HPS yet. You have HP for these areas, but you don't have an HP for the swell here. So you're missing HP and LPs for the swell for your plaza. I see you have an HP. Now let's make you have an HPS here. Make sure you use the center line type, okay? And here it should be an LPS, all right? Okay. Huge errors. It seems like we have an extra contour here, but maybe just my, yeah, I think that's right. We have the 6 going like this, and then it kind of collected here. It shouldn't connect here, okay? The last contour here you have is actually 7 over here. So there's an error of how 6 is connected. 7 was wrong, okay? 7 should be wrapping around, because this is your, that's your 8, and this is a closed contour, and your 7 should go wrap around like that. And make sure you check the 6. 6 was wrong, shouldn't connect to the curve over here. And 5 looks okay. All right. And definitely you are missing contours at the bottom. Reason being your previous BFFE was wrong. If the bottom FFE is 99 point something, your next contour should be 99. And you should figure out how 99 gets back to the 99 over here, okay? It doesn't seem a big problem over here, but it could be problematic on this side. All right, 99 is a pretty high, it's a pretty high elevation. And we just need to make sure that the contours here can connect to your 99 at the bottom of the plaza. So those are some of the obvious things that I can see. This is not 13, that's 12. Okay, your 12 goes down to the 12 here. So the connection here is actually correct, but this labeling, that one is 12. This one works, that's the 13. This, make it more clear like this instead of following the curve, okay? You know, that is a little bit of, yeah, change the shape of this 12 a little bit. So those are the big things that I can see from distance. Anything else?
I don't get it.
Are we good here? Move forward. All right, not sure if you left the room. Zach here?
Yeah.
Okay. All right. So let's take a look at the retention. So you have it here, there, okay. Right. You have something here, you have something here. There, seems to be missing, yeah, you're missing someone here. Okay, that's a dead end. That DI needs to be treated. And also, honestly, you need something over here. At this point, I might just include a green area somewhere here to connect these two. All right, so that one and that one needs to come into a retention somewhere. For this side, you have 1, 2, 3, and that one. This side it's pretty good. You have one more here. I would cut a hole again, another hole in the middle, because you have a pretty big, big plaza, half plaza over here. Okay, cut some holes. This one is not receiving a lot of water unless you use a trench drain, right? This is the drainage area for that one. That's pretty small. So I probably would either put a trench drain in and have the trench drain direct into the retention, or I would just cut holes. I might just choose to cut holes in the plaza, relatively downstream, just to reduce the I might make it even elongated a little bit, like this shape, not that shape, but well, I'll just draw it. make it the shape of this, so it kind of collects more. All right, so, one thing you definitely need to do is this thing in the middle. Right, you see the water, it's kind of pounding over here, so you need to cut it open, cut this open, and have something over here. Okay, so that's the first thing, and the other two things are cutting more holes in your plaza. That's the retention you need. All right, overall, good location of the retention areas. Do you need to raise your BFFE? It depends on what your the TFFE works, but your BFFE is exactly 10 feet lower. Right? Yes, you need to raise it. Okay, and the BFFE is not written on the plaza. Okay, BFFE needs to be written here, and it's 98.6. And the plaza needs to be graded according to the 2% slope, right? So these elevations all needs to be recalculated. Okay, so that's the bottom plaza. Okay. Keep going. How do I label at the end of the center line? Well, here you just need to label the spots here. Okay, because for this swell, the end of the swell, the LPS here is the curb. So you just need to label the curb cut. Okay, and here you would need to label LPS. Right, for this one, you need to label LPS. For that one, you do not need to have anything special. This is basically the ridge line, right? The ridge line, you would extend it to your building, and you would need a spot outside, actually, you know, on the pavement. The spot you just calculated, and you do not need any other labels, basically a spot elevation there. Okay, so that is that one. And where do I need ramps? You have a ramp over here, so that's good. Remember to angle your contours against the wall to direct water away. Okay, and then what other ramps you would need? It seems like you designed a ramp here, which is great. In that case, your ramp should actually be somewhere here. And it would be kind of shared in between your two. So this is where this is the lower part, and that is a ramp going down. Does that make sense? This is the second type of the ramp. This is the flat area. In the middle, this is the flat area. That is an extension of the your parking lot. And your slope arrow should be going down, flat, and then go up. Does that make sense? So this is where your ramp needs to be for these two parking spaces. All right. And you don't need a ramp over here because this is basically, you know, already getting onto your plaza. So that's good, right? You need another ramp over here. That's the more traditional type of ramp, you know, like this. So those are two additional ramps that you would need. Curb ramp. So big things that are missing. Yeah, these contours look like they will be working fine here. I would polish, no, we're missing a contour here of 13, right? We need to close the 13. So it's likely that everything here needs to shift 4 feet to that direction because this is the 13. Okay, so your 12 needs to be somewhere here. Does that make sense? And then the 13 needs to be cut here as well. So these needs to be shifted a little. And your retention swell or divergence swell needs to be dragged up a little bit. Right? So that needs to be revised. I would, for these, I would not shape it up, kind of to continue the swell anymore. I would stop with the number 7, right? Oh, no, number 8. Sorry, actually number 6. 7 should go, still go like this. My 6, I would tend to just do this. Okay. You know, if you want to, you can have one more. You don't necessarily have to. You can have one more little retention here to receive some water from the swell here. Not necessarily have to. If you just wanted to sort of flow this way down, kind of spread into a sheet flow manner. So starting from the 6th contour, I will get rid of the swell signature and basically do something like this. Okay. I think so far the work shows good understanding of the material. Just keep going. Okay. Anything else? Go ahead.
So what if I made that, where the 88 weapons are, if I just drop that whole entire thing instead of just dropping it in front of the.
Oh, okay. That works too. If you want to drop the entire thing for this whole thing,
I'm talking about just the three spots, like the 30 foot that'll be in between the end of the one ADA, like loading area to the end of the other.
I'm not sure I got it.
So like where you drew the lines,
Mm-hmm.
all the 3 lines,
Yeah.
instead of just having those middle 2 lines be dropped, everything to the end of those lines. Be all
So you want this to be just a paving line instead of curb, right?
Not that stuff could be curves too, but I'm saying.
If you have a curb, if this is all curb, then you need a ramp that goes up and then go down. Yeah, unless the whole thing here, it's just paving, it's just the parking lot. And then you just have one ramp goes up from here. You can do that. You can do that. But I personally think, you know, having a sidewalk all the way along that is on top of the curb, that it's a better solution. It doesn't take much to do the curb ramp over here. I would just do a curb ramp, and then honestly, I would put the 2 shadings together. Let's see. So it's better if you put the ADA sign. So if people are parking here and there, honestly, okay, now I see you actually need one more dividing line here because they're sharing. You have more ADA spots than necessary. You can get rid of these 2 and just retaining those. Those are 4, right? If that's the case, we can basically say, I don't need that one. I don't need that one. And folks the car will be parked over here, and then they will be rolling down to this, right? And then this is the landing area in the middle that's flat. And then this will be the slope, the part of the ramp, and then the other part of the ramp. And the slope arrow should go going down and then going down like that. That make sense?
Yeah.
Yeah. And I think you're the only one that is using this solution, and then I think that's a good one. Okay. Anything else?
So if I did that trench drain on the 7 contour,
Mm-hmm. train train on the 7 contour, okay. You would want it to be put downstream, right? You could put it somewhere here. Just right there would be okay. Yeah. Yeah. And you can also put it down here. That's okay too. In that case, you'll be receiving the whole thing. The whole thing because they're draining, well, yeah, they're draining down to, well, I take it back. If you put it over here, it's only going to receive this much. So it's about the same if you put it down, no, up a little bit with a longer one. It will. So if we're not doing it here, then it's okay. It's not, it will not affect the ramp. Okay? Yeah.
What if that string extends like off the top that way? So you just put the.
Let's not do that. Let's separate the trench drain with the ramp because trench drain, it has a vertical volume. It goes down, right? So you wouldn't want a trench drain to overlap with a ramp. So if we put the ramp over here, our trench drain, you could put it there, but I would say this is a better spot for that ramp going up. Okay, you want to try to have the ramp stay away from the swell because you can imagine water will be flowing along this line. So you would want the ramp to stay away from that swell line. And I think this is a better location for the ramp. And you can put the trench drain over there.
Some sort of cutoff along that, along the swell. Like on this.
No, you don't, water will just keep flowing down there. Yeah. Yeah, it's this direction. Curb cut should be over there. Right? On the lower side instead of, yeah. Okay. Anything else?
I know you said, file retention on like the right corner of that.
Yeah.
Area.
Yeah. It was a little noisy. So this should be where it needs to be. Yeah.
I'm saying like, on the other side of that block.
Mm-hmm. So this is for on this side of the curb, right? So this is for this area. On the other side, it all drains down to here. So I wouldn't, you mean in this area?
No, lower than that.
You have one over here. Yeah, you have this one at the end of the flow route. So I think that will be okay. It's mainly this curb, right? This curb prevents the water keep flowing. So you need something to receive this water here.
Okay.
All right.
You said a drain input, another drain input on the. Okay, yeah.
Yeah, those are the 2 locations. Okay, good. Yeah, we are at time. I'm gonna stop recording so we can start converting the video.